Hey guys, so in this video we're going to build on what we already did with fractions. So in the last video we were just representing fractions in really basic models. Well, today we're going to be comparing fractions and noticing when fractions are greater, less than, or equal. My biggest piece of advice is when a question is asking you about two fractions, draw two models. Draw two rectangles, or two circles, or two number lines to help you, okay? So here is an example. So first let's talk about equivalent fractions. And when two fractions are equivalent, even though they might not look exactly the same, they take up the same amount of space. So if we look here, let's say this is a chocolate bar and it has two big chunks. It's broken into two chunks. Here's another chocolate bar and it's broken into four small chunks. Well, if someone eats one big chunk of their bar and this person eats two small chunks of their bar, even though this person ate one big chunk and this person ate two little chunks, they ate the same amount. So this is 1/2, and since they ate the same amount, because it takes up the same amount of space, 1/2 eating one of the two big pieces is the same as eating two of the four small pieces, okay? Because look, they take up the same amount of space. Let's look at another example here. Let's say that someone has a mini cake and they broke it into 3 big pieces. This person has the same mini cake, but they broke it into 6 small pieces. Well, if this person eats 2 of their big pieces, we need to figure out how many pieces does this person need to eat to have the same amount left over. Well, if I look, and a big suggestion I have is if I'm shading in on this side of the rectangle, I should do it on both. If I'm shading in on this part of the circle, I should do it on both. That way it's a lot easier for my eyes to compare. So I'm going to be shading towards the top. So if they eat 1 part, nope. 2 parts, still less. I'm wanting them to be the same amount. 3 parts, no, but I'm getting there. 4 parts, oh, look at that. Even though this has 1 big piece and 2 small pieces, they both have the same amount left over and the same amount shaded in. So that means 2/3, 2 big pieces, is equivalent to 4/6, 4 of the small pieces, okay? All right, last example would be on the number line. So let's say that I hop here on the number line. Well, if you remember, this is 2 parts, and I hopped 1 of them, so 1/2. All right, how many parts, would I need to hop here to make it equal? Well, nope, getting closer. Yes, if I hop here, that would be too far. That would be like going here. So it's right here, so let's look. 1, 2, 3, 4, 5, 6, 7, 8. I hopped 4 of the 8 parts on my number line. So 1/2 is equal to 4/8. All right, now, so you might already be given 2 models, or you might be given something like this. How many halves are equal to, that's not gonna work. That's not gonna work. How many halves is equal to 4/8? Well, I'm not given models, so guess what? But I have 2 fractions, so I'm gonna draw 2 models. Rectangles are my favorite, but I do practice my circle and number lines. You practice whatever's best for you. So this one has halves, but it doesn't tell me how many to use. So I'm going to skip it for right now, and I'm going to come over here. This one's giving me 4/8, so I'm going to turn this into 8ths, and I'm going to shade 4 of them. 1, 2, 3, 4. Ooh, are you seeing it? If I shade it in 4/8 to make it the same, I just need to shade in 1/2. So 1/2 is equal to 4/8. We actually saw that down here too. All right, so that is equivalent fractions, all about trying to land on the same spot in the number line, take up the same amount in 2 circles, into rectangles. Well, fractions aren't always going to take up the same amount of space. Sometimes there's going to be a lesser fraction and a greater fraction. Sometimes someone's going to eat more of their chocolate bar or eat more of their cake or run a longer distance. So you need to be able to figure that out. But again, if it gives you two fractions, use two models. That's what I do. I will talk through another way of thinking also, but the simplest way is I have 4/8 and 6/8. So I'm going to draw two fractions. They're both eighths. And I'm going to shade in 4. 1, 2, 3, 4. I'm going to copy these eighths down here. And I'm going to shade in 6. 1, 2, 3, 4, 5, 6. Well, look at that. They both have 8 pieces, but they're not equal. This one goes all the way over to here. So that means 6/8 is greater than 4/8. 4/8 is less, okay? Another way to think about that is, let's say these are two people having chocolate bars. They both broke them into 8 pieces, but this person only ate 4 of their pieces. And this person ate 6 of their pieces, okay? So that's another way to think about it. Here, two fractions. What am I going to do? Use two models. All right. This time, 1/4. 1/4. Let me erase a little bit. And this one is 1/8. Now, some people, I've seen this before, they go, oh, this is greater, it has an 8 in it. Watch this. Look how little that piece is. It only goes to there. This one goes to here. That's because this one was only broken into 4 parts. This one, they had to break it into 8 parts. More parts, smaller parts. So they both used one of their parts, but this one has bigger parts. So 1/4 is greater than 1/8. All right, now down here, if we go back, these both had 8 parts. These both used 1 part. Well, these don't have anything that's the same, so definitely use a model. All right, 2/3. 2 of the 3 parts are shaded. All right, and then 5/8. 5 of the 8 parts. 1, 2, 3, 4, 5. Ooh, it's close. But look, this one went to here and this one came to here. So this one's a little bigger. 2/3 is a little bigger. All right, one last thing I want to talk to you about, and it's actually going to come back over here to the equivalent fractions. Sometimes you might be given a model and it might ask you to think about it in more than one way. Okay, so right away I see sixths. 1, 2, 3, 4, 5, 6. And 2 of the 6 are shaded. That's exactly what it's showing. But could it be showing something else? Well, let's think. Sixths come from thirds. So if I go backwards and I turn this into thirds, do you see these 3 parts? Do you see it as thirds now? 1, 2, 3. Well, one of them is shaded. So in one model, I am actually seeing 2 fractions. 2/6, and I could turn it backwards into 1/3. So that was kind of going backwards into that one, but I didn't want to forget that idea. All right, so use these as reminders for when you're doing equivalent fractions that do take up the same amount of space and comparing fractions that do not. And my biggest reminder, if you're given 2 fractions, draw 2 models, whether you use rectangles, circles, or number lines.